Welcome to the Caribou Data Science channel. It's the evening of Friday, October 19th in Central Ohio. I'm just going to go back and give you a quick walk through the report I generated earlier. And basically what it does, it compares the daily cases and deaths for three different sources. And the three COVID-19 sources are the European Center for Disease Prevention and Control, the New York Times, and of course the Johns Hopkins University. Now, the European data is daily data, means it shows the totals, shows the total new cases and new deaths for each individual day. Johns Hopkins and the New York Times uses cumulative data, which means it adds up yesterday's totals into today's totals, and today's totals into tomorrow's totals, which means that the numbers have no place to go but up. It also means we have to subtract today's number from yesterday's number in order to get the new cases and deaths for today. And for that, we use what's called a diff function. We'll see it in just a second. So let's just go ahead and get things started here. Open up our code here. Okay. So pretty simple up here. Nothing really radical. Turn off some messages. May use Plotly, or probably not. Do the initial data load for the data from European Center for Disease Control. Do a and this is data, and then come down here, sort the data, make sure it's sorted by date, and then come down here and convert date to a date field, and then fill out the initial data. This is for the cases, as you can see. Because the first case in the U.S. was reported on January 1st, 2021 or 2020. This is a subset. The first death, COVID-19 death, was reported in the U.S. on the on February 28th. And this year, I just decided to eliminate the first few weeks of nothing. So there's nothing of zeros. Okay. So let's take a look here at this and see exactly what's going on. So we can load this, and we could load this. So currently we are averaging 28,922 cases per day in the U.S. and 945, 946 deaths. Now the deaths, of course, are tracked from the first death, from the first case on, from the first death. Though the first death was February 28th. Okay. Then they did a subset from 3-1, which isn't important, but and I calculated the mortality rate, the death rate. So now we come down here, we got some more data. Now we're actually pulling out the other two data sets, New York Times and Johns Hopkins. Now the interesting thing about this is, of course, we pull out only the date for the cases. Then we calculate a total cases by month. Okay. This doesn't make any sense. Huh. No, that's because, okay. This is right, because the New York Times data set has actually has the daily data is already calculated for it. Okay? So this makes perfectly good sense. So we created an aggregate function by date of cases, then an aggregate function by date for deaths. And now we come down here is when we get a little more trickier, because the Johns Hopkins data does not have it split out. So first we pull in the data for the U.S., then we convert a date function. Then we use a diff function which says lag 1. So it means, for instance, what happens is, it's going to subtract yesterday's numbers from today's numbers, and that'll give us the new cases and new deaths for today, and so forth. Because again, Johns Hopkins uses cumulative totals. So if you subtract yesterday's cumulative total from today's cumulative totals, that'll tell you how many new cases or new deaths you have for today, and so forth. Okay, and down here, I just recreate a date series for our data, because this is just simply the cases number. So now we create a case down a date sequence down here for the cases, and we do the same thing down here with deaths. Okay. So now let's begin with our. So let's just start. Let's just go ahead and run the report from the top. So I don't want to take up too much of your time. The way of doing the plots is identical all the way down. The only thing that changes is the data. So let's take a quick look at this. Okay. Now you can see there's nothing special about this plot. This is a straight XY plot. This is the data frame. I'm using ggplot2. Okay, so this is the data frame. I'm going to plot a line, and I'm going to plot on the x-axis the date and the y-axis the cases. Then I'm going to label it as daily cases. Okay. Now I'm going to point the plots over top of that, but it's just a GM point. Again, it's passing the AB, the data frame is passed down to here. Now we use, once again, we point, it's the same plot as a line, but now we're plotting individual data points. Now it gets a little bit more interesting, okay? Uh, I'm using the smooth function, geom smooth. And what this does, this creates a low S or low S fitted curve for the data. Okay, the AES is the same. The colors labels the data, and the span. I'm not quite honestly quite sure what span does, but it gives us a better fit. Then all they do is just create a a title for it, and it's the same way for cases, and it's the same plot for all three data sets with cases and deaths. So let's just go ahead and run this report from the top and actually take a look at how this data actually looks. Okay, so once again, we're up here. Average number of cases per day, average number of deaths per day. Now, here we go. Here's the first, now once again, the dots are the actual data points, the actual number. The lines just connect the dots, so to speak. The blue line is what's called is the low S fitted curve. It's similar to a moving average, except it uses a different weighting scheme. Okay, so what we see with cases is the double spike, a larger spike here, a much larger spike here, a decline here, almost back down to here, but now it's starting to climb up again. Again, this is the European Center for Disease Prevention Control, and what I want you to see is how all three of these plots for cases is almost identical. It's certainly close enough for government work, as we used to say, okay? Because now we're looking at the John Hopkins data, but you notice there appears to be more data points up here, which is kind of interesting. Uh, but anyway, the important thing is the shape of the data is almost identical. The data is telling the same story from both John Hopkins and the European Center. Double spike followed by a third increase. New York Times data. Now you can see this is slightly different here, but nonetheless, it's still the same basic shape. And I'm concerned with trends and the shape of the data, not the individual data points. And you can see we had a decline here in cases, back up. So now let's take a look at the deaths by date. This first, of course, is the European Center for Disease Prevention Control. I want you to notice this. This was a spike back in April. Okay, look at the deaths. Look at the cases up here. Look at this. Okay, the actual cases here is the cases are much lower here, but the deaths were much higher. Now the cases are just spiking crazily, but look at the deaths. In actual fact, the deaths began to decline back in here and have declined continuously for since, well, I don't know, maybe if that's April, this is May. Okay. Okay, so let's, oh man, we got scales in here, don't we? I wonder if we could plot the x-axis again. Break it down by month. Okay, let's just take a look at scales again. Continuous. Okay, what I'm going to try to do here, start with this first plot here, I'm going to try to modify the x-axis so it has It's by month. Okay, let's see some. Let's try date. What we want to do is we want to say this should be month day. Let's try this. So let's see if this will give us months. Better. Okay. So this is 3, 4. Okay, this is much better actually. Let's go ahead, add this down to all the other plots down here, okay? We could, of course, rotate the plots, but it's not really necessary for these, I don't think. Okay. So also going to do, we're going to add a plot line, a month label to all these things. If I wanted to rotate the labels, I would actually use part of the theme function, but we're not going to do that right now. Okay, so let's go back. Let's go back. We run the report. Okay, so here we go. Average number of cases per day, average number of deaths per day. So now we got our lines for each month. So what we can see here is now this is April, this is May. So the first spike in cases is back here. Now this spike up here, here's July. So this spike up here was late July. Okay, this is the European data. John Hopkins data, pretty much the same thing. Spike back up here. Okay, follow with the lowest curve, fitted curve. Another spike back up here, spike up here, sometime around late July, early August. Maybe well, this is late July, and now it's been going down ever since. Again, it actually, okay. Thirdly, New York Times cases. Okay, again, the same situation. April, May. May it did actually spike between April and May. This spiked late July again. Now let's look at deaths by dates. Okay, we can see this spike in deaths looks like uh, late July, late April, early May. We spiked here. So as far back as so you can see what this means is as far as back as May, the deaths have been declining since May. And it resumed even because this is lower than this. This spike here is lower than this spike. And the whole thing is trending downwards. Wow, that's interesting. Okay, let's see something. Okay, so this is the European numbers. This is John Hopkins numbers. You can see the deaths are still similar pattern. This seems to have a little bigger spike on it than the European data. Not really sure why that is. Okay. Um, but the important thing is this is April, May. So once again, we see the continuing decline down here. Uh, and technically, both of all these data sets should have the same number of data points. But the important thing is this: here we are. This is lower than this. Yes, it dipped down here a little more, then came back up. But now, once again, it's resuming its downward climb. So we have 2 or 3 data sets so far showing us that deaths and cases showing us that deaths are decreasing. Now let's look at the final data set, the New York Times data set. Notice this spike here? You don't see that spike. Well, right there it is, but you don't see it over here, which is kind of interesting. But once again, here's the spike, April, May, a long decline down, a small little speed bump here, I'm going to call it, and a resuming decline. Okay? So once again, what we see here is deaths are declining continuously. Continuously. Okay? This little spike here doesn't really mean anything except it gives us the point to see where the second decline is going. I mean, as long as the deaths are staying below us up here, or even below this right here so much, we're doing okay. All right, we're doing okay. So anyway, thanks for spending a few minutes with me this evening. I hope you learned a little bit. First, about how simple it is to once again use ggplot to analyze data, how simple it is to use a simple function like diff in order to extract the daily data from a cumulative total. And of course, we have 3 sources, both basically telling the same story. European Center for Disease Prevention and Control, New York Times, and John Hopkins all tell the same story as far as cases and deaths. And the story as far as deaths continues to be declining deaths. Declining deaths. So once again, so much. Thanks so much for your for your for your for your time and your input. And if you have any requests, hey, don't just put in the comments below. And also, if you haven't done so already, click the red S button in the bottom right hand corner and subscribe to the Caribou Data Science channel. That would mean a great deal to me and give me the encouragement I need to continue on. Thanks so much. We'll catch you on the next report.